Alright, we want to talk about graphing quadratic functions. And a quadratic function, as you know, is anything that has a square as its largest exponent. So in general, we could say ax squared plus bx plus c. Now this is what we call a standard form. Okay, it's different from the vertex form where we were doing transformations, right? So this is kind of what you'd seen in the past for a quadratic. And of course you know that the graph will be a parabola. That's the name for the shape of any quadratic, that U shape. Okay, so we're going to graph this using, basically using a table of values, because of course any function can be graphed using a table of values. But for a parabola, it's real critical to get that vertex point kind of figured out where that is. So when we graph, we're going to do a couple things. We're going to find the vertex, and for some additional points, we will find a y-intercept, and maybe one other point. And then we're going to use symmetry to graph some more points, okay? So let's go through this. How do you find a vertex when you don't have this vertex form? It's kind of awkward to find it. But there's a handy-dandy formula we're going to use. X is equal to minus b over 2a. So at the vertex, your x value will be minus b over 2a, and then find f of x for y. Okay? So now we have the x and y of the vertex. Y-intercept, how do you do that? Well, that's just the same old rule we always had before. You simply set x equals 0. So we're always going to put that in our table of values. And then we'll pick some other value nearby. And then we're going to use symmetry, because remember, the axis of symmetry was always given by x is equal to the x of the vertex. Okay? So that's a vertical line that goes through the vertex point. Alright, so let's see how this works. Okay, so here's a quadratic function. I wrote it with a y equals. And I want to find the vertex. Well, the vertex, x, is equal to minus b over 2a. And in this case, that will be x is equal to minus 6 over 2 times a is 1. So I guess I'm assuming you all remember about quadratics when you write it in this sort of standard form, that it's, you know, ax squared plus bx plus c. So in this case, a was equal to 1, b was equal to 6, and c was equal to negative 2. I'm hoping you all still remember how to do that. So let's go back and find our x is a negative 3. So that's that. Now let's find the y value. Y is equal to a negative 3 squared plus 6 times a negative 3 minus 2. So we're getting 9 minus 18 minus 2. What is that? Negative 9, negative 11, I think. So now I have the vertex at negative 3, comma, negative 11. That's good to know. And of course we'll find the y-intercept by setting x equal to 0. So y is equal to a negative 2. So I have another point that is 0, comma, negative 2. And it would be nice to have one more point that perhaps lies between those. I'm not ready for that, sorry. Let's let x equal negative 1. So then y is equal to negative 1 squared is 1, minus 6, minus 2, and I'm getting negative 5, negative 7. So I have this point, negative 1, negative 7. So there's 3 nice points I can put on my graph to start with. Let's do that. Alright, so I'm going to put those on my graph. Negative 3, negative 11, down there somewhere. 0, negative 2, that's my vertex. No, sorry, this was my vertex, my bad. And negative 1, negative 7. 1, 2, right down here. Okay. I also want to label now. We're going to start using symmetry now. Remember, x equal negative 3 is my axis of symmetry. So let's make sure I get that on this graph. Went through there and goes down through the vertex. Now, every value that I have on there that's not the vertex is going to have a symmetric point. So this point here is going to be symmetric across that line. So 2 units away, I put that one. This has a symmetric partner 3 units away from the axis of symmetry, right there. Okay? So that's using your symmetry, using the axis of symmetry to reflect that. Now I can connect this smooth. Now I can connect this smooth curve, like so, and I've got it. And I can, of course, label all of these. The new ones that didn't already have a name, kind of figure this out here. If this is -3, 4, 5, and 6, -6, comma, -2, and -5, comma, what was that one again? -7. Alright, so there's labeling some more points as well. Okay, I want you to try this graphing this function x squared plus 4x minus 3. I'm going to go ahead and pause it and we'll come back and compare our answers. Okay, so there's my graph. Oops, I just have to still connect the dots. Down and up. Like that. And I have those extra points that I found through symmetry, -4, -3, -6, and 9. So hopefully you were able to follow finding the vertex, get that on your graph, find the y-intercept, put that on the graph. I chose x equal 2 because I already had this point, and I wanted to get one more point. Maybe x equals 1 would have been a nice point as well. But I just wanted to get something on the same side of the curve just to help me out a little bit there. Okay, we want to talk about minimums and maximums. So that's obviously something that's very important to us in math classes and lots of other places. So let's find those mins and maxes. But first, is there a min or a max? Because of course not all of them have one. And the deal is this. If a is a positive number, okay, so a is greater than 0, then, you know, there's no vertical reflection, right? When we talked about transformations, we said a was negative, there would be a vertical reflection. But we say, nope, there's no vertical reflection, so the graph opens up, right? It's like the arms of that graph are up in the air. It's going on and on forever in the up direction. So it opens up when a is positive, and so we got something that looks like this, and this vertex is a minimum. Okay? So we have a vertex that is a minimum. Let's think about the other example. Let's go to a is less than 0, so you have a negative number. Then there is a vertical reflection. I've now reflected it so that it opens down. So the vertex is a maximum. Okay, so you have this idea opening down, so this would be a maximum of the function. And you have to remember, what is being maximized here is the y value, right? So the maximum of the function is the maximum y value on the graph, okay? And it occurs at the vertex, so you could find the x of the vertex, you found the x of the minimum or the maximum, and then you can just find the y value of the vertex to give you what the value of the maximum or minimum is. Okay? So remember, we had that thing, x is equal to minus b over 2a, that formula for finding the x of the vertex. So now that's for the minimum and maximum too. But the f of x is the min or max. Okay, so that's that. Let's try one of these just for fun. Let's go ahead and find the minimum or the maximum of this function given here. So we will say x is equal to minus b over 2a. finding x, I'll get minus 12 over 2 times negative 4. X is equal to negative 12 over negative 8. Really? I'm going to have to get a fraction. I'll divide everything by 4 and get 3 over 2. Okay, that isn't my maximum yet, but that's the location of it. Okay, so now that I know where the maximum or minimum occurs, I'm going to find what is that value. Let's see, so f of x is equal to, it's getting late, I'm a little punchy. Oh gosh, do I really have to do 3/2 in this thing? Alright, plug it in, chug the numbers, I'll be right back. Okay, so I'm really trying to find, I should have written f of 3/2, lovely that it is, and the answer that I got when I stuck it all in there is 27. Okay, so that's, the vertex is 3/2, comma 27. That you could say is your vertex. But what you also can say is, ooh, is it a min or a max? I forgot to check. How do we tell? Oh yeah, I have to go back up here. It's negative in the front there. So that means it opens down. Oh, that means the vertex is a maximum. Okay, cool. So now I can say the maximum is 27 at x equal 3/2. Okay, so I've talked about the maximum value and where it occurs. Alright, and it is a maximum, not a minimum. The other thing that's really great about finding mins and maxes is now we can do range, okay? I mean, domain's easy, right, guys? Domain, of course, oh, let me just go to the next page. Okay, the domain will always be, so don't get this wrong, all real numbers for quadratics. Okay, there's no restriction on x. X can be anything at all. Okay, so all real numbers. But range, range is a different story, of course, because, you know, you've got this parabola shape going on here. So the answer to range is going to be the minimum value and above, or the maximum value and below. So in my last question, I had the max. What was it again? It was a maximum 27. Maximum was 27. That's the y value, right? So that's the range, because we remember domain is x values and range is y values. So I can say now for the problem that I did previously, the range is, if that's the maximum, 27 is the maximum, and minus infinity then would be the minimum. So there would be my range. Alright, so now we can do domain and range now, too. So, good to go.